mean, everybody at Cray is aware that the depth and strength of the computing history that Cray had with NCAR. And we heard from Tom that the serial number 3 provided a big leap forward from sort of sheer computational power. What over the years, could you maybe characterize what's been the drag on computing? Has it been networking? Has it been external storage? Has it been compute power? What, of that triangle that's needed for an effective supercomputer, what's dragged the most over the years, would you say?
I'll put in 2 cents worth and then turn it over to Dick. But first, in the early years, it was I/O. It was getting data to and from the disk. In the 80s, 90s, and even today, it's memory bandwidth that limits our computing power. On the vector machines, the Crays, NCAR models could sustain between 30 and 40% of peak. And that's because on the Crays, Seymour put a lot of effort into matching memory bandwidth to the computational power of the machine. And that really has been lost over the years as we've gone to distributed memory systems. Our models now, rather than 30 to 40% of peak, are lucky to get 2% of peak. And it's just because we have multi-processor systems, but you can't get the data in and out of memory. And so, if that, in fact, when Seymour was killed, he had just started in the auto accident. He had just started SRC. He was working with Intel to actually design a memory subsystem. SRC's whole intent was to design a memory subsystem which could match the I/O bandwidth to and from memory that the Intel processors demanded.
Yes, I'll put in my 2 cents here briefly. In that, in the early days, we really didn't have, as this is my memory, we really didn't have many forecasting. We didn't have those kind of projects at that time. So basically, a lot of our work was done with long-term integrations. I can remember that some of our users actually ran their integrations for a whole year. That's real time, a whole year of real time to get the results that they needed for their research. So NCAR, the R stands for research. So pretty much the emphasis was on that. Now, today things have changed, and we do a fair amount of forecasting, but basically still I believe the bulk of our work is still developing the research, the models and the climate research, things like that really don't involve forecasting.
Will it use, common to some of the more recent machines, will there be a bigger emphasis on sort of like graphic chip processors that I know a lot of machines have used to speed their processing?
Yeah, about 20% of that system will be powered by GPUs. Our target was 80-20 split.
Yeah, I'll just add a word here that one of our a couple of our flagship models one is called WRF, Weather Research Forecasting System, and another is called CESM. And my understanding is that the WRF model is somewhat poised to use the GPUs, whereas CESM is not. It's about 2 million lines of code now, as I understand it, and I think there's some idea that the GPUs will actually be very useful in some of the post-processing, like the graphics, as Summer was mentioning. But right now, I'd just like to say that I think that we just have to wait and see. It's like when the Cray 1A first came here, we really couldn't foresee a lot of how it was going to be used. And I think in a year or so after it's on the floor, we'll start to see those applications coming forth.
Excellent. So once you've stretched its computational legs that are many and long. Fantastic. All right. Thank you, Summer.